Good morning. This is day 25, April 24th. And let's start with reading our question here for AMI day 25. Newton's third law states that for every action, there's an equal and opposite reaction. This is the basis for how rockets work. We launched rockets in the fall. A rocket can be as small as your finger, as large as a skyscraper. An essential feature of any rocket is that it expels gas in one direction. That means it shoots out the back end. A rocket moves forward when the gases shoot out the back of the rocket and push it into the opposite direction. That's why when we launched our rockets in the fall, we didn't stand too close to and we didn't stand behind them. And we also used our safety goggles. Let's continue. A rocket's altitude, that's how high it is above the ground. Okay. Use the graph to answer the following questions about how a model rocket's altitude changes over time. Remember, altitude is how high it will go. So number 1, what two variables are being graphed? And in what unit is each being measured? This in the red here are your sentence frames. So when you submit these to us, please go ahead and start with number 1 and say the two variables being graphed are, and let's look at this graph. We've got it here on altitude, and apparently it looks like it's cut off a little bit. There we go. It's time. Let's see if I can get this fixed for you guys a little bit better. There. So moving this down here, so we look at altitude and it's measured in meters, time is measured in seconds. Number 2, what is the independent variable? And the independent variable is, remember, dry mix. DRY, D stands for dependent or responding, and that's on your y-axis. And mix, it's an acronym for manipulated or independent, and that's on your x-axis. So the question you guys can see is, what is the independent variable? That's going to be on your x-axis. So what is that showing you? Okay, pretty easy. Number 3, what was the rocket's altitude after 2 seconds? So we're going to look at 2 seconds here in our time and just go up. And what do you see? That's going to be what you estimate that number to be, and that's what you put down for number 3. Number 4, what is the rocket's altitude after 4 seconds? Let's go here to the 4. And 4 seconds. Keep going up, 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 up. Okay. And what do you see as the altitude at 4 seconds? And I've got the top tip of the pointer on that one. So that would be question number 4. Question number 5. At what time did the rocket reach its greatest altitude? So it's asking you in time in seconds, and it reached its greatest altitude. Look and see, where do you see the highest altitude? And take it across. And what does that time say? There you have it right there. Yes, this is kind of easy, but I want you guys to see the graphs aren't that hard to read. And number 6, it says, why do you think the rocket continued to rise after it ran out of fuel? Because here's the note that said the rocket used up its fuel right here. So I want you to think for a second on the law of inertia, kind of like Newton's first law. An object in motion will remain in motion. An object at rest will remain at rest unless acted upon by another force. So take that into regards to when you answer this. I think you'll do a great job. Have a great day.